Welcome back, class. I'm Mr. Teacher with the SAT Math Video Guide, and last time we left off on test number 3, section 2, number 6, and today we'll be starting on number 7. So, let's get started. So, number 7 says, in the circle above, pentagon ABCDE is equilateral. What is the ratio of the length of arc ABC to the length of arc AEC? So they tell us at the beginning that pentagon ABCDE is equilateral. That means since a pentagon has 5 sides, if we divide the if we divide the pentagon to 5 separate segments, all the angles will be equal, so it will also be equiangular because the pentagon is equilateral. So this is equal to this, is equal to this, is equal to this, is equal to this. So if the angles are also equiangular, the same angle everywhere, that means that since there are 5 separate segments, the angle of one side will be 360 divided by 5. So let's quickly figure out what that is. 360 divided by 5. 5 goes into 35 7 times. We get a 1 left, and that's 2. So each angle will be 72 degrees. So by this, we can figure out, we don't need to add up every single angle to find the length of arc ABC. So arc ABC, let's just give these all 72, 72, 72. Okay, so arc ABC is, if you look at it like this, it's 2 equal arcs. So you could just write 2. You don't need to include the angles in your measure. You just need to know that count the equal arcs together. So arc ABC is 2 separate arcs, and that's all. And arc AEC is 1 separate arc, 2 separate arc, and 3 separate arc. They didn't tell you the D because D, you don't need to say the D. That's how you notate an arc. If it contains more than 3 points, more than 3 points, then you name the first point, the second point, and you go as far as you want to the other point. So there are 3 equal arcs on AEC, 3 equal separate arcs. So the ratio of length of arc ABC to arc AEC is 2 over 3, which is just B. So B is the correct answer. Now we'll move on to the next problem, number 8. And there's a line here. Let's try to draw it properly. There we go. That's much more better. Goes this way. Goes this way. Okay. This is 0. And this is -1. And this is 1. And the points are labeled B, C, D. E is on 1. And A is on -1. So, tick marks are equally spaced on the number line above. Which of the lettered points has a coordinate equal to -1/2 whole squared? So, it says the tick marks are equally spaced. So, from 0 to 1, if you go 4 tick marks, then you figure out that each tick mark is 1 over 4, or 0.25. Yeah, each separate tick mark is adding 0.25 or subtracting 0.25 in this case. So we need to figure out what -1/2 whole square equals, which is -1/2 times -1/2. These just turn into pluses, and 2 times 2 is 4. So 1/4. Now, which one is 1/4 on the number line if they're equally spaced? Well, this is 0.25, this is 0.5, this is 0.75. 0.25 is what we're looking for, so that's D, and the answer choice is D. Now we'll move on to the next problem, number 9. And I've been thinking about this. I want your feedback on it. whether I should make my videos a little longer or a little shorter, because now I can post videos more than 15 minutes, which I had a limit on before, maybe about 3 days ago. So anyways, so the problem is, if t is greater than w, how much greater is the sum of s and t than the sum of s and w? Well, there are three numbers then. There's s, there's t, and there's w, and I stated this inequality here already. So let's pick values. Let's say s equals 4. Let's say t equals 7. And let's say w equals to 5. So, how much greater is the sum of s and t than the sum of s and w? Well, s plus t is equal to 11. W plus t is equal to, no, s plus w is equal to 9. The difference between these is equal to 2. Well, if we look at the answer choices now, let's start with the middle one always, all the time. So c is t minus w. And if you do that, it's 7 minus 5, which is also equal to 2. So we know now that c is our answer. However, if you're a bit confused, like if you want to check whether it really is the answer, let's pick another set of numbers. Let's say s equals to 3, t equals to 11, and w equals to 4. So s plus t is going to be equal to 14. S plus w is going to be equal to 7. 14 minus 7 is equal to 7. And 11 minus 4, which is t minus w, is also equal to 7. So it's always correct, no matter what set of numbers it is. Just this condition always has to be true. If it's not true, it's not going to work. If it's true, it's going to work. So, that being said, let's move on to number 10. Which is an equation, okay, that's a bit involving lots of fraction powers. So 3,000 times 2 to the power of t divided by 4. So very intense problem. So some organisms are being cultured in a biology lab. The population P of the organisms in the culture T days after the culture began and is modeled by the function above. By how many organisms does the population increase from t equals 4 to t equals 16? So, it's just knowing your powers properly. So, the increase between if t equals to 4 to t equals to 16. So, let's just solve this equation. So, if t equals to 4, then population of t is equal to 3,000 times 2 to the power of 4 over 4, which is just 1, which is just nothing. It's just 2. So 3,000 times 2 is 6,000. Now let's look at the population of t if t equals to 16. So that's 3,000 times 2 to the power of 16 divided by 4, which is equal to 3,000 times 2 to the power of 4, because 16 divided by 4 is 4. So 3,000 times 16, 2 to the power of 4 is 16. So 3,000 times 16 is, so another small tip, I'm not going to bring out a calculator here, but for these long multiplication problems, if you don't have a calculator and you need to figure it out quickly, well, you should know this trick by now. Forget about the zeros. That's not a 1. That's just a long dash. So 16 times 3, we all know, hopefully, is 48. If you've done your multiplication problems, multiplication tables lately, it's 48. So now you just add 3 more zeros to the end of it. So it's 48,000. Now we need to subtract 6,000 from 48,000 to get the difference. So that's 0, 0, 0, 2, 4. So the total increase is 42,000, and that's choice D. So now we'll move on to the next problem. Okay, the next one is number 11, which says, if the average of 3 S and T is 5. What is the value of s plus t? I hope I read that right. Okay, so the average of 3s and t is 5. So 3 plus s plus t divided by 3, because the average is the sum of all the terms divided by the number of terms. This is equal to 5. So let's multiply 3 on both sides to get rid of this 3. So 3 times 3 plus s plus t divided by 3 will cancel out the 3. So it's 3 plus s plus t is equal to 5 times 3, which is 15. So now we subtract 3 from both sides. S plus t is equal to 12. And that's our answer. We don't need to go any further than that. That's choice E. That's choice E. Okay. Now we'll go to number 12, which is a Venn diagram. Venn diagrams are always fun problems. They sometimes tend to give people problems. However, in reality, they're pretty simple, but they're not simple to draw. Oh dear. There we go. Oh, come on. I want it perfect, but I at least wanted a circle. There we go. Close enough. And there we go. Okay, so these circles are labeled A, B, and C. And A is 3, 5, 4, 2, 7, 6, and 8. 7, 6, and 8. I hope I did that right. 3, 7, 8, 5, 2, 4, 6. Okay, so now let's read the problem. The figure above is a Venn diagram that represents sets A, B, and C. The number in each region indicates how many elements are in that region. How many elements are common to sets A and B? Okay, so the numbers common to sets A and B will be the numbers in the intersection of A and B, and the intersection of A and B is right here. I realize now I should have used another color for this, but either way, it still works. So the intersection is right there. So it includes 5 and 2, and no more. So 5 plus 2 is equal to 7. And that is the number of elements common to sets A and B. And that is choice D. Okay, so I believe we can do another problem. So we'll do number 13. Hopefully I don't run out of canvas space. That's starting to worry me a little bit. But anyways, so State University plans on accepting... Oh, this is number 13, by the way. The State University plans on accepting a total of 1,000 students for next year's class. Of the 800 students accepted so far, 60% are female and 40% are male. How many of the remaining students to be accepted must be male in order for half of the total number of students accepted to be male? Okay, it's kind of weird, but it's solvable. So a total number of 1,000 students are going to be accepted, and so far 800 have been accepted. Out of these 800, 60% are female and 40% are male. So 0.6 x is equal to female, 0.4 x is equal to male. X is, in this case, equal to 800. So, for starters, we need to find how many females and males are in this group of 800 students. So, 800 times 60%, which is just, okay, give me a second here. 100% is equal to 60%. 800, 60 is equal to, okay, so what we need to do is multiply 800 by 0.6. Did I do that right? Yeah, I did that right. So 60% of 800 will be, okay, I'll cut the thing here because I'm getting a little bit confused in my head. It should be pretty simple. Okay, actually no. So we can figure it out like this: 100% is equal to 800, and 60% is equal. Actually no, sorry, 1% is equal to 800 divided by 100. So which is just 8, and 60% is going to be equal to 8 times 60. So 8 times 6 is 48, and you add another 0 to it. Okay, I don't know, I kind of had a brain fart there, but so there are 480 females, and to find the males is just 800 minus 480, which is 320 males. So how many more need to be accepted for the rest to be, so there are half males and half females. So half of 1,000 is 500. So we just need 500 minus 320 more boys to have an equal number of boys and girls. So that is just equal to 80, 180. So that is choice D. So let's see what the next problem is, though. Okay, so it's an equation. So I'll just stop right here for now. And I hope this helped you with your math preparation. And I will see you in the next video. And I don't think I'm going to cut out that part where I start pondering because I didn't think for too long. But anyways, I'll see you soon. Take care.